Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video on graphing polynomials. So you already know what a polynomial is. We're now going to take a polynomial equation and turn it into a graph. So we're going to do it by finding these things. So for the polynomials we go through, and we're just going to do cubics and quartics, degree 3 and 4 polynomials. We're going to find the y-intercept, which is really easy. We're going to find the x-intercepts, which requires what we've been doing with factor and remainder theorem and polynomial division. And lastly, we're going to look at the limiting behavior. So that means what happens to y as x approaches positive and negative of infinity. So you can read that as what happens to y as x gets larger and larger, or x gets more and more negative. So let's start with an example. So we're going to graph y equals x cubed plus 2x squared minus x minus 2. Now the first thing to do is find the y-intercept. Well, that's easy. It's always the constant term, just like it was when we did quadratics. So the y-intercept here, of course, if x is 0, all of that will equal 0. We're just left with minus 2. The y-intercept is 0 minus 2. So now we're going to find the x-intercepts. So we let y equal 0, and we end up with this equation here. Now, we've been solving these heaps before. So remember, what we do is we first look at factors of the constant term, minus 2, positive and negative factors, and try and find which of them works. So let's try, for example, x equals 1. So, of course, if x equals 1, and I substitute into this equation, I get 1 cubed plus 2 times 1 squared minus 1 minus 2. Well, that does equal 0. I get 1 plus 2 minus 1 minus 2. So x equals 1 is a root of this polynomial. So that means x minus 1 is a factor. So remember, once we've found one linear factor, we can keep going in this way and use trial and error to find the other linear factors, or we can use polynomial long division. Of course, trial and error, trying to find other factors the way we just did, might not always work. There might actually not be any other factors. So that's why I'm going to use polynomial division. So let's go ahead and use polynomial long division. So how many times x go into x cubed? Of course, that's x squared. So now I multiply x squared by x minus 1. So x squared times x squared times minus 1. And remember, at each step, you subtract to find the remainder. So 2x squared minus x squared gives me 3x squared. And 3x squared divided by x is 3x. So now I bring down the next term, and I times 3x by x minus 1. So 3x times x, 3x times minus 1. Once again, I subtract in order to get the next coefficient. So minus x minus 3x gives me positive 2x. So if I divide that by x, I get positive 2, bringing down the negative 2, sorry. And now 2 times x minus 1 gives me 2x minus 2. Remainder is 0. So I know I did that really fast. Please look over my video on polynomial long division if that was too fast for you. So please pause and copy down the polynomial long division if you want it, because I'm now going to rub it out and write x cubed plus 2x squared minus x minus 2 as the product of two factors. So this is what I have from the polynomial long division. Now I've got a quadratic. I can factorize this in the usual way, two numbers that times to 2 and add to 3. And I now have x minus 1. And those two numbers that times 2 and add to 3 are positive 2 and positive 1. So I have split my polynomial into linear factors. So remember, the reason that I did this is it makes solving it so much simpler. So the solutions to this equation are just the negatives of each of these coefficients. So the solutions are 1, negative 2, and negative 1. So these will be the three x-intercepts of my graph here. So for any cubic, it can have up to 3 intercepts, x-intercepts that is. It can't have any more. So I'm done with step 2, I found the x-intercept. So now I'm going to look at step 3, the limiting behavior. What happens to y as x approaches positive or negative infinity? Well, it turns out that's determined entirely by the leading coefficient. So in this case, the leading coefficient is 1. It is positive. What is going to happen as x gets larger and larger? So as x approaches positive infinity, this term's going to dominate. It's going to be way more than all the other terms. Now, if you take a really large number and cube it, you get a really large number. So what I'm saying is, as x gets larger and larger as it approaches infinity, y is also going to get larger and larger. That's because of this term here. It's going to get larger and larger as x gets larger and larger. Now, as x gets more and more negative, what will happen to y? Well, once again, this term is going to dominate. When you take a negative number and cube it, you get a negative number back. So what is actually happening here is, as x gets more and more negative, y will actually get larger and larger, but more negative as well. And that's because of this term here, the first term, x cubed. So now we've got all the information we need. Let's turn it into a graph. Okay, so we've set up our axes like this. So let's start with the y-intercept at 0, -2. Let's mark that. So then we mark the x-intercepts at 1, -1, and -2. So it's going to go through these. So the thing is, we don't sort of know, is the graph coming from up here or is it coming from down here? The limiting behavior tells that. It says as x gets more negative, so as x is going this way, becoming more negative, y is becoming more negative. So y goes down here. So it tells us we're actually coming from down here. So what's going to happen, this is a curve, remember, it's going to come up and it's going to go through -2 through the axis. Now eventually it's going to stop and turn around and go through this x-intercept. It's going to go down and go through the y-intercept. Again, it's going to stop and turn around. And what the limiting behavior is telling us is that as x gets larger and larger, so as x is going this way, y is getting larger and larger. So it's going to go off like that. So that's just a rough sketch. And that's all you need to be able to do at the moment. Now, there's a few things we don't actually know. We don't know where this turning point actually is. It could be up a bit further. It could be lower. We don't know about this turning point either. So for now, you don't need to calculate the turning point of quartics or cubics. You'll learn that when you do calculus. You don't have the mathematical skill to do that at the moment. So you can just estimate for now where the turning points might be. So just make sure you've got arrows on both ends of your curve, and it will look something like that. Again, a rough sketch is all I'm after. So let's now go ahead and we're going to do an example of a quartic. So we're now going to graph this equation here, y equals x to the power of 4 minus 3x cubed minus 3x squared plus 7x plus 6. So we start by finding the y-intercept. That's really easy. Constant terms just 6, so the y-intercept is 0, 6. So secondly, we want to find the x-intercepts. So again, to find the first one, we find roots of this by checking positive and negative factors of 6. So if we try x equals 1, it turns out we won't have any success this time. 1 is not a root of this polynomial in blue. It turns out -1 is a root of this polynomial. If I substitute x for -1, it will make this polynomial equal 0. So that means x plus 1 is a factor. So again, I could use polynomial division to find what polynomial I need to multiply by this to get y, or I could use trial and error to find other factors. Again, there's no guarantee that this will be able to be split into linear factors. Now, it turns out for this one, it will work out like that. So let's try other factors of 6, both positive and negative. It turns out positive 3 is a root of this polynomial, and it also turns out that positive 2 is. So x minus 3 and x minus 2 will be factors. So once you've got 3 factors, you can find the fourth really easily. Once you've got all but 1 factors, it's easy to find the last one. So what do I have to multiply by -1, by -3, by -2 to get positive 6? Because if I expand this out, that will be the constant term. I will need to multiply this by x plus something, and that something needs to multiply by -2, -3, and positive 1 to get positive 6. So 1 times -3 times -2 is already positive 6. So this one here has to be positive 1. So that all 4 of these numbers multiply to give the constant term. So this is actually x plus 1 squared, x minus 3, x minus 2. So it turns out this one has x-intercepts at 2 and 3, but it turns out that -1 will actually be a double intercept, and I'll show you what that looks like in a second. So let's now look at the limiting behavior. What happens as x gets larger and larger? Well, once again, this term here, x to the power of 4, will dominate. As x gets larger and larger, it's going to be way larger than -3x cubed. So as x gets larger and larger, so too y gets larger and larger. If you raise a really large number to the power of 4, you get a really large number. Now, as x gets more and more negative, the thing to note is that x to the power of 4 is the same as negative x to the power of 4. So if you take a really large negative number and raise it to the power of 4, you're going to get a really large positive number. Again, we don't need to look at these other terms. It's only the leading term that dominates. So as x gets more and more negative, y will get larger and larger, but it will still be positive. So this is slightly different to what we saw with the cubic. All right, now we're ready to draw a rough sketch of this graph. So we set up our axes again, and let's just plot what we know. So we know the y-intercept is 6, so I mark that here. So the x-intercepts, we have an x-intercept at positive 3 and 1 at positive 2. Now, x equals -1 is actually a double root, so it's also going to be a turning point, just like we saw with quadratics. When you have something like, x minus 1 squared, the x-intercept was the turning point for a quadratic, and it's the same here. So now we have to look at where the graph is going to come from. Is it going to come from up here or down here? So as x is getting more and more negative as we're going this way, as we said, y is getting more and more positive. It's getting larger. It's going that way. So the graph is going to come from up here. So it's going to come down to this intercept of -1. Now, it's a turning point. So this is what a double root or a double intercept looks like. It's a turning point. It turns around on that point. So then it's going to go up, and it's going to hit y equals -6. And eventually it's going to stop and need to turn around so that it can come down through x equals 2. It'll stop and turn around again and go through x is 3. As we said here, as x gets larger and larger, y gets larger and larger, so it will shoot off to infinity. So this is what the graph looks like. Once again, we know this turning point, but we don't know exactly where these two turning points are. They could go a little higher or lower than I have drawn, but we're not too worried about that in what we're doing at the moment because we don't have calculus, we don't have the requisite understanding. Just remember, when we're graphing these quartics and cubics, all I'm after is a rough sketch based on these features. Alright, I know this is really hard. You're a superstar if you understand any of this. Thank you so much for watching. This has been the luckiest maths teacher in the world. Have a great day.